Now we're ready to move on to Newton's first law, and Newton's first law is one of the first very important laws of physics, and it's actually so important it's worth knowing the exact definition. So the law goes as follows. It says every object in a uniform state of motion tends to remain in that state of motion unless an external force is applied to it. So let's go through and see what that means. First of all, we're dealing with objects, or masses. So we're looking at a single object, and a uniform state of motion just means it has a constant velocity. It's going at the same speed in the same direction, not changing. And then it says it tends to remain in that state of motion. It means that the motion doesn't change, so there's no acceleration. And then unless an external force is applied to it. So really what that's saying is, if force equals 0, then acceleration equals 0. Now going back to the law for a second, there's another very interesting point. It says external force. Now what this means is a force coming from outside the object. This is why no matter how hard you pull, if you grab the top of your boots, you're never going to be able to pull yourself up in the air, because that's an internal force. It's a force you're exerting on yourself. Now if someone bigger comes along and grabs you by the boots, they can lift you up by your feet. But if you're just pulling yourself up on your own, you're not exerting an external force, so you'll tend to remain in whatever motion you're staying. Now at first this law seems really obvious. We're saying if there's no force, there's no acceleration. Well, that's exactly what we defined force as. But to other people, this was completely groundbreaking. The ancient Greeks for a while believed something completely different. They believed objects had directions and speeds they liked and didn't like going in. So if you let a rock fall, a rock liked going in that direction. It actually wasn't a force, it was just its tendency to move in that direction. But if you tried to roll a rock sideways along a grassy field, the rock didn't like that, so the rock would slow down. And it would be a sad rock. Now, to us, this theory seems completely crazy, but for hundreds, maybe even 1,000 years, this was a common theory, that there were directions that objects tended to move in or tended not to move in. And Newton stepped in and said something completely different. He said, don't think about it in terms of the object, think about it in terms of the forces. If the rock is slowing down, that's because there's a force of friction. If the rock's falling, that's because there's a force of gravity. That all of these interactions actually are caused by different forces. And sometimes the forces aren't obvious, and sometimes that can actually be used to predict a variety of things. For instance, this was actually how we discovered what used to be the planet Pluto, which is we noticed certain planets should have gone in certain directions based on the forces we knew were being exerted upon them, but they were actually going in slightly different directions. Now we could have just decided, oh, it's drifting and just it's doing that on its own, but that doesn't make any sense. An object moving at a constant velocity will keep going at that constant velocity, unless there's some force exerted on it. So we started to look around and try to find a force that could have caused that. And we decided there must be some gravitational force pulling on it. And we looked and we looked and we looked, until finally in the exact right spot, we found Pluto. And Pluto is exerting a gravitational pull, and causing them to drift ever so slightly. And so any time the first law of physics seems like it's broken, that it seems like, maybe something's moving without a force causing it, you need to look back and see maybe there's a force you missed. Is there a force of gravity, a force of friction? Is there a wind blowing on it? That so far this law has proved 100% accurate. And that means that anytime it seems like it's broken, that's almost always a sign that there's some new force or some force that we've missed that we need to take into account. So now that we've looked at this this law in terms of words and descriptions, now we're ready to look at it in terms of the mathematics. And the mathematics of this law are very simple. It says if the sum of the forces, where sigma means all the forces combined, equals 0, then acceleration equals 0. So there's no force, there's no acceleration. Hopefully that made sense. There's some quick questions to test your understanding of this, and then you're ready to move on to Newton's second law.